Okay, algebra nerds. So here we are. We're going to go into linear functions. This will correspond to assignment 19. By the way, did we mention the Chiefs won the Super Bowl? Yeah. All right. So anyway, this is assignment number 19. Linear functions. Example number 1. We're going to talk about what's called a slope-intercept equation. So, our first example, y equals 3x plus 5. Well, first of all, that'll create a graph, as we mentioned, because of the two variables, x and y. We have x and y. So, just like on the homework, we'll have these boxes to put your answers in, and we have some graph paper here for you to graph that function. First of all, let's talk about the fact that this would be a line, because both variables are to the first power. All right, linear. Remember we talked about linear equations are those where our variables to the first power. So if both variables, for our purposes, are in to the first power, that'll graph out as a line. All right. Now, the nice thing about this particular equation is it's already in what we call slope-intercept form. You maybe have heard of y equals mx plus b. This looks like that. So actually, this first example is already in the slope-intercept form, and therefore we can transfer it immediately into that there box that wants the slope-intercept equation. It's already in that format, y equals mx plus b. Now let's talk about why we desire that. Okay, when you graph things, in my opinion, when you graph a line, you first of all need to establish a beginning point. All right, let's talk about the significance of the B out here. All right, well, that's going to lead immediately to what's called a y-intercept, because that's going to be an ordered pair, and it's going to be on the y-axis. That's why it's called the y-intercept. And so you look at this and you say, I want to plot a beginning point. I'm going to stick a number in for x. What number would be the easiest arithmetic possible here, do you suppose? What do you think? Mr. Soap Dispenser wants to know. What would be a smart number to plug in for x? Anybody? 0! I like it. Good idea. 0 is a smart number to plug in for x. Because look, if we plug 0 in for x, wouldn't 3 times 0 basically disappear, and y would immediately equal the number 5? That there number sticking on the end. That their b number sticking on the end. So whenever we plug 0 in for x, y would immediately equal b, wouldn't it? That their number sticking on the end. And that would lead us to the ordered pair 0, that their number sticking on the end. So x is 0, y would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that would give us a beginning point. So I like the fact that we call it b. It's going to help us establish a point from which to begin the graph. Hopefully that makes sense. By the way, I spent an hour of my life making that arrow spin. Woo! All right? So there would be the b value. Once we have our beginning point, wouldn't it make sense that we then need to move from that point to another? Move, m. All right, we've talked before about the fact that in the United States we call a slope m. All right, and I like that because that to me makes me think move. So very easily from that equation we can identify the slope. It's the number in front of x, the coefficient of x. So the slope here would be 3. Now we talked on assignment 18 how a slope is rise over run, vertical change over horizontal change. We did the slope dance. 3 is not a fraction. Is it? Or is it? Is 3 a fraction? Oh yeah, it's 3 over 1! That's right. So this would be 3 over 1. So the point is, once we've identified our slope, we can rise 3 and run 1 from that beginning point. So we will come back to this beginning point. We will rise 3 and run 1 from that beginning point. 1, 2, 3, up, 1 over, up 3 and to the right 1. There's our secondary point, and then we can just draw our line. All right? So there would be a very easy graph. So that question was very easy.
That was easy.
Because it was already in slope-intercept form. So you start easy and you build from there. So look at that, M. Oh, look. Okay, I forgot how I made this arrow spin. So that arrow's spinning. Watch this. Woo! That arrow spinning was another hour of my life trying to remember what I had done to make the other one spin. But anyway, what an idiot. There you go. Now, y equals 3x plus 5, I have to share with you, has a lot of significance for me in my life because it turns out that my daughter Andy, that happened to be her very first graph, y equals 3x plus 5. So that has very special meaning in my world, and I tend to get a little bit emotional whenever I graph this. And so, in fact, there's y equals 3x plus 5, and you know, here's a post I put on Facebook a few years ago, but our child's first steps, our child's first words, our child's first graph of a linear function, y equals mx plus b. Today's Throwback Thursday, let's pretend it's Thursday, is a look back at Andy's first ever graph on our chalkboard in the garage of the equation y equals 3x plus 5 from the summer of 2005 between her first and second grade years. To this day, I still use y equals 3x plus 5 as the first example when we graph linear equations in my algebra classes, and it will always bring back fond memories of this cherished moment with Andy Sodergren at Sodie's Math Garage. Cherish those moments with your children. They grow up so fast. I love you, Andy.